says if x, y, and b are positive real numbers, where b is not equal to 1, and r is a real number, there are certain properties that logarithms have. All right, now you're going to write these. Look up here. Start right at the left. You're going to write them in this space to the left. Here, Jack, did you get one of these? Do you have the handout there? Okay, here's property number 1. Now you're writing on the handout. These are the properties. If you have the log of a product to a certain base, look what I'm doing here. You have the log of any product to a certain base. This equals the sum of the logs. In other words, the log of x times y means the same as the log of x to the base b plus the log of y to the base b. Okay, so that's the product rule. If you would mark that on the paper just like I did up here. I'll show you how to use these in a minute. Property number 2. If you have the log of a quotient to a certain base, look at how I'm writing this. The log of something over something. This is equal to the log of the numerator to that base, subtract the log of the denominator to that base. So this is the quotient property of logarithms. Log of a product, sum of the logs. Log of a quotient, log of the numerator, subtract the log of the denominator. Property number 3. You have the log of a power. Watch this. X to the r to a certain base. Now, watch this. And then I'm just going to show you how to use these. And these properties are going to be used to do other things later, next week, after this week. This is the log of something to a power. This is equal to r times the log of that base. This is the power property of logarithms. Let me just summarize. Log of a product, sum of the logs. Log of a quotient, the log of the numerator, subtract the log of the denominator. Log of something to a power. Now you see where that power ends up going? In front of this, and then it's just the log of that base. Now, you have room? Okay, I think you have room. On your paper here. You have room over here to the right? I think you probably do on your paper. In the blank space on your paper to the right, you need to write down those two things right there. Go ahead. On that same space to the right of the paper, you need to write down those two things right there.
How much space you would leave?
It's just one thing.
Oh,
It's just going to be one term I'm going to write in there. It ain't going to take much room at all. I kind of want you to tell me what's going to go in the blanks. That's why I wrote it like that. Those are like special properties. If they come up, the answers are like immediate. You see why I keep saying positive here? You can't have the log of a negative number. Everybody. Next week, I'm going to do things on your calculator with logarithms, and I'll show you. It won't work. It'll say error. That's why I'm always saying it's got to be positive. Now, I would think somebody should be able to tell me what goes in that first blank after what I've done the last couple days. Remember, what does a logarithm stand for? An exponent. If this and this are exactly the same number, the log of b to the base b, I don't care what it is, the log of 5 to the base 5, the log of 13 to the base 13, the log of 100 to a base of 100, what will that answer be every single time? answer to a logarithm, what's it stand for? The exponent. Nathan, do you understand that? B raised to what power would give B? Now, do you understand it? It's got to be a 1 every time. You have the log of 5 to the base 5. 1. You have the log of 10 to the base 10. 1. So, easy way to remember it. When these two things are exactly the same, the answer is always a 1. How about this? I think I gave you this the other day, but let's make it official here. What would be the log of 1 to any base?
0.
Okay, so if those ever come up in a problem, and they will, those are the answers you would put down right away. All right, fellas, again, this isn't going to take too long, I don't think. All I'm going to show you today is how to use the properties. You see all this stuff written on the board? They're on your paper. Now follow me on the paper. Here's the directions. And you'll see this in your book. It's going to be on page 685, and here's what the directions are going to say. Use the properties of logarithms, there they are, introduced in this section to express each logarithm as a sum or a difference or as a single number. Okay? Some of these are going to be like one step. Now these are on your handout, so follow me on the handout. This is the log of 6 times 9 to the base 5. They just want you to expand that using these properties. So what do you do when you have the log of a product? All I want you to do now is to apply these to the problems. Don't know what I mean? Look, the log of x times y is the log of x plus the log of y. What's the log of 6 times 9? Just apply the property. Expand it out. What's the matter? First one's easy. Rob.
Log of 6 to the base of 5 plus log of 9 to the base
Log of 6 to the base of 5
plus log of
plus the log of 9 to the base of 5. Now watch what's going to come up in these next few problems. That's done. You did what the directions said. All these problems are telling you is use these properties and expand the problem out. Now look at this one. The log of 3 times x. Tell me what to write down. The log of a product. 3 times x. Oh man, come on. These are easy. Just do the same thing I just did. 3x is the product. It's 3 times x. Jack.
log of 3 to the base 3
Log of 3 to the base 3
plus log of x to the base 3.
plus the log of x to the base 3. Now, come on, I need to see if you're paying attention here. That ain't done yet. Are you paying attention to what I just talked about not even 5 minutes ago? That's not done yet. It's not done yet. It's not simplified as far as it can go. Andrew.
The log of 3 to the base 3 is just 1.
Here's that property over there. See it? That's 1. You would put equals 1 plus the log of x to the base 3. Now, you see the one we just did? You might say, well, how come aren't these done? What's the log of 6 to the base 5 mean? Doesn't that mean 5 raised to what gives 6? Think about what I just said. 5 raised to what power gives 6? Well, you ain't going to be able to give me an answer to that in your head. It'd be quite impossible. That's why you can't go any farther there. That's why you can't go any farther there. Now, what about this one? Let's use the property. A log of 7/9. Here it is. Just expand it out. Just use this. Ethan.
The log of 7 to or base 4 minus log of 9 base 4.
You're done. I know some of you are sitting there going, that's all you got to do? There's more coming later. I just need to get these properties in your head. That's all we're doing today. Use the properties and expand them out. Okay, the bottom one there. Tell me what the right here. Log of 27/5 to the base 3. Go ahead, use your property. Come on, somebody, give me. Howard.
Log of 27 to the base 3 minus log of 5 to the base 3.
Pay attention. This one's not done yet. Come on, this is where you guys got to be attentive or observant. Can you simplify either of those logarithms there? Why am I saying it's not done? That's not done yet. Adam.
Because 3 to the third is 27.
Remember, I kept saying a logarithm is an exponent. Doesn't this mean 3 raised to what power gives 27? So like the first thing I taught you. So the log of 27 to the base 3 is 3. And then you would just bring this down. Done. Okay, flip your paper over. Flip it over. All right, now this is going to go really fast. Really fast. See this one here? When you have the log of something to a power, power comes out in front times the log of the base. Oh, this is like a one-step problem. What's the log of m to the 5th to the base b? Well, just use the third one now. All I'm teaching you today is how to use the properties. That's all. So what's this equal? Number 3. Ethan.
5 log of m into the base b.
5 log of m to the base b. That's done. Give me the next one. Come on, these are fast. Give me the next one. The log of 4 squared to the base 5. Just use the property. David.
2 log 4 to the base of 5.
2 log of 4 to the base 5. Give me the next one. Rob.
3 log of x to the base 4.
3 log of x to the base 4. Now, be careful here. Look at this one. Be careful here. Some of these are going to have more than one step. Isn't this the log of a product? So what's the first thing you're going to write down? Property 1. It's the log of 4 times x cubed. Give it to me. Property 1. What's the matter? I did logs of products right here, and I did it here. So what's the log of 4x cubed? That's 4 times x cubed. So what's the first thing that means? What's wrong? It's the log of a product. Just this was the log of 6 plus the log of 9. This is the log of 3 plus the log of x. All right, do the same thing on that. There's 2 things there. Andrew.
Log of 4 to the base 4 plus log of x cubed to the base 4.
With me? Log of 4 to the base 4 plus the log of x cubed to the base 4. This isn't done yet. Continue. It's not done yet. It's not done yet. Tell me. Noah.
No, you simplify to 1 plus the log of x3.
Whoa. When you have the log of an exponent, we just did it here 3 times. What's the log of x cubed mean? Property 3. We just did it 3 times in a row here. Log of x cubed. Noah?
Would be
No, we just did it 3 times here.
3 log x 4.
Okay, there you go. Now it's done. Now, here's where you gotta be smart. Look at the rest of them on the paper there. And you can see the note I wrote there. And you should have already known this. Let me see the paper. Is there one off to the right? Okay. This one right here. When you have radicals, first you got to write them with the exponent. Now you should know how to do that already. So my question to you is here, log to the base b. What's the square root of 7 with a power on it? This is everything we've been doing for the last couple weeks now. What's the square root of 7 with something to a power on it? Quinn? 7 to the 1/2. So now go ahead and use your property. I just erased it, but property 3? John?
1/2 log 7 base.
Now, right to the right of that, it says the log of the 5th root of x squared to the base 2. Come on, you guys gotta be smart here. What's the 5th root of x squared written with a power? This is all stuff you've already learned, you can't forget it. What's the 5th root of x squared written as an exponent, Rob?
Actually, 2/5.
X to the 2/5. So, use your property. Final answer is? Steve, come on, use your property, there's something to a power. Nathan?
2/5 log of x to the base.
All right, look at this one. You got it. Pay attention here. There's 3 more on here. These are the most involved ones. How are you going to write the square root of m over n? Now, pay attention here, because I'm finishing up. These last 3 are just a little bit more involved. You got to convert the radical to exponential form first. Well, what's the matter? So what? It's a fraction. The square root of m over n. Rewrite that so it's something to a power. That's all I'm asking you. How?
Log to the m to the 1/2 n to the 1/2.
Now, don't simplify it yet. If it's a square root of the whole fraction.
Oh, then just m over n to the 1/2.
Did you hear that? M over n to the 1/2. You all see that now? Square root of, now you gotta use your property. Where's that power gonna go now? Well, we've just been doing it like 3 or 4 times here. Keep going now. Now use your properties now. Joe?
1/2 log 7, or 1/2 log m to the base 7 minus 1/2 log m.
Well, hold on. One thing at a time. Hold on. You're jumping ahead of me. Look. 1/2 log of m over n first, okay? Power goes in the front. Now, that's not done yet. Listen to me. This is the log, this is going to be the log of m, subtract the log of n, correct? What do you think I have to put after that 1/2 though? Let's see if you can. This is 1/2 times that whole thing. So what do you think I have to put on the board there after the 1/2 before I write that out? I have to, because it'll apply to the whole thing. This is 1/2 times that whole thing. Chris, a grouping symbol. So now, what's the log of m over n? Go ahead, Campbell. Now you were saying it.
Log of m to the 7, or base 7, minus log of n to the base 7.
Are you done? Is there anything more you can do? The directions, I'll read it to you again, are going to say, use the properties to write each logarithm as a sum or difference. Technically, there's one more thing you would technically have to do there. And then you would just have something plus or minus something. I mean, it's a simple step, but technically you would have to do one more thing there. Howard?
You just have to distribute.
Exactly. Just distribute the 1/2 through to everything. 1/2 log of m minus 1/2 log of n. Now, go ahead on your paper, do the next one by yourself. Go ahead, just use the properties that I've been going through here. I'm almost finished here. Go ahead and do that one by yourself. Give me your first line of work. What do you see here? A log of a fraction. So that's property 2, right? Give me the first line of work, somebody. Come on, we're almost done. Give me the first line of work. Jack.
Log of a squared minus log of b.
Everybody see that? The log of this, subtract the log of this. Now, it's not done yet. You gotta keep breaking these down so they're as far as they can go. We didn't do it this thing, because there's a power there. I've been doing it over there. Rob?
2 log a to the base of 5.
2 log of a to the base of 5 minus, now, come on here, be smart. This is the log of a product, but what am I gonna have to put after that minus sign though? Because it's for the whole thing. You gotta put it in there. Ethan,
Minus the quantity of log e to the base of 5 plus log c to the base of 5.
did you say plus or minus?
Plus.
Plus the log of c to the base of 5. And technically, there's only one more thing you probably need to do here. What am I talking about? And then it's written as a sum or a difference. Mike,
Flip the signs.
flip those. So this is 2 log of a minus the log of b to the base 5 minus the log of c to the base 5. Now, do you see how all the answers are looking? What do you see in every answer? You see the log of something plus or minus some other log. Yep.
Do you have to write out the first one, or can you just go to the second step? Like, I just went to the 2 log.
Okay, I knew someone was going to ask me that. Look, be careful when you're doing these, because I don't want you starting with this and say, bada bing, there's the answer, and you got nothing in between. That's what I don't want you to do. Yes. I suppose you can do that.
All right.
What about the last one on your paper? What's the first thing you would do? What's the first thing you would do in that last one? Come on, we're just about finished here. Yoo-hoo! Rob, convert the radicals. All right, what's the 4th root of z? Now just convert to exponentials. What's the 4th root of z with a power? Rob? Z to the 1/4 times 5th root of w. 5th root of w. Adam.
Log w to the log base of 4.
No, hold on. No, I'm just rewriting these. I already brought the log down. Just rewrite the 5th root of w.
W to the 1/5.
W to the 1/5 over v squared. Okay. Now what? Everybody, look. Isn't this the log of this subtract the log of that, right? But the top's a product. So, Estes, you just asked me this, and you can do this. Do you all see that this is gonna be the log of this plus the log of this, because it's a product, subtract the log of that? Do you all see that, just using the properties? This is the log of z to the 1/4 plus the log of w to the 1/5 minus the log of b squared to the base 4. What's the only thing left to do? And that's done. Why isn't it done? There's only one more step. You can't leave it like that. Why? Because you must take care of the...
Exponents.
That's right. So, go ahead, Quinn.
1/4 log of z to the base of 4 plus log of,
No,
Or
1/5 comes in front.
1/5 log of w to the base of 4 minus 2 log of b to the base of 4.
Okay, now that these are all done, up here, you see all the answers going across the board? Isn't it some log is something, or a number times a log, plus or minus another one, plus or minus another one? All right, go to your iPads. Go to your iPads. Take